Okay, in this presentation we're going to look at correlation and covariance between random variables. So let z be a random variable with mean 0 and variance 1, and let x be a random variable independent, that's important there, of z with mean 5 and variance 4. Okay, so let let y equal to x minus z, so it's the difference of the two. Okay, calculate the correlation coefficient between x and y. So the covariance is, we're going to build this up bit by bit. We need the covariance of x and y, we need the variance of x and the variance of y, and then we'll piece it all together to find the correlation coefficient. But first off, we'll start off with the covariance of x and y. The covariance of x and y can be written as the covariance of x and x minus z. Okay, now this expression here we can break up. Okay, so we have two terms here, the x minus y. So we can actually approach each of those two parts of that difference there with the other x. So we have x and then x and z. So, oops, let's go back there. The covariance of x and x is simply variance of x, and that is 4. So we have x minus z, so we have minus the covariance of x and z. Okay, now we recall that to be independent, so that's 0. Okay, that's why that's important to pick out. So the covariance there is going to be 4. Now we're told in the question that the variance of x is 4, so that part was straightforward, we're told that. Now the variance of y is the variance of x plus the variance of z. Okay, now this is a difference of x minus z. Okay, but when you want to find the variance of that difference, you add the variances of the two components. Okay, that's important. That is not a typo. It's plus there. Okay, if you add the sums, so x plus z, you'll do the same thing. It will have the same variance. Okay, so the variance of y is the variance of x plus the variance of z, which is 4 plus 1, which is equal to 5. Okay, so we piece it all into this formula here. The correlation of x and y is, this is a sort of standard identity here, this part here. Okay, and what we're going to do is use our values that we've determined here. The covariance is 4, the variance of x is 4, the variance of y is 5. The square root of the variance of x times the variance of y is the square root of 4 times 5, square root of 20. Okay, so 4 divided by the square root of 20, that should give us 0.894. Okay, that's grand. Now, what I'm going to do here is just quickly try a different technique here. Same, or just actually sort of approach it from a different angle, partly just to get the most out of the question. Okay, so we're going to do it the same sort of way, even follow the same sort of approach overall, but we're just going to look at a couple of things from a different point of view. So by independence, now so we're just starting again. By independence, it is immediate that x has mean and variance both equal to 5. Okay, so we knew that already, that the mean is equal to the means are the mean of x, the expected value of y is the expected value of x minus the expected value of z. Okay, and that was, what was it, 5 minus 0. Okay, and also the variance of y, we're going to use this here, this part here again, and remember it's plus this time, even though this is a minus, so it is 4 plus 1, so it's 5, so they're both equal to 5. Okay, now this is an important identity to remember. Okay, and it's sort of the reason why I'm doing this a second time using this approach here. So the covariance of x and y is the expected value of x times y minus the expected value of x times the expected value of y. And we just work those out. 4 times 5. 5 times 5 actually. Okay, so actually I'll just sort of make a note of that there, that is 5 times 5. 5 and 5. Okay, now the variance of x and the variance of y, we've just sort of figured that out. We're given that, and we're given that. Okay, That's actually pretty much just sort of almost identical to the last question. So that's the square root of 20 there. Okay. So the thing we have to look at now is the expected value of x times y. Okay. So what we're going to do here is use this identity here. Well, try and space it out a bit. The expected value of x times y is the expected value of x times x minus z. Okay. And that is equal to the expected value of x squared minus the expected value of x times z. Okay? And the expected value of x times z is going to be 0 by definition. So essentially the expected value of x times y is going to be the expected value of x squared. Okay? So, by the way, by independence of x and z implies that the expected value of xz is equal to 0. It sort of follows on from independence. So, using standard results, the expected value of x squared equals variance of x plus the expected value of x to be squared, which is 4 plus 5 squared. Again, this is what we're told in the first part of the question, and that is equal to 29. If you're wondering where this comes from, this is actually simply a restatement, a rearrangement of this standard formula, which really you should be familiar with at this stage. Okay? For random variables. So it's just a rearrangement of that. That's all it is. And what we're asked to do is find out what this is. Okay? So essentially we have all our values. So we're starting back to where we were before. The correlation equals the expected value of x times y, which we now know to be 29. We subtract 25 and divide that by the square root of 20, and then we get the same answer there again. So that's it. We'll leave it there.